The title of this objective is Factor Difference of Squares. In number 1, we're being asked to factor this expression that we need to recognize is the difference of squares. When we have an expression that's the difference of squares, we can factor it to the square root of the first term plus the square root of the second term times the square root of the first term minus the square root of the second term. So in number 1, I can take the square root of the first term, which is 16x squared, plus the square root of the second term, which is 25y squared, times the square root of the first term, which is 16x squared, minus the square root of the second term, which is 25y squared. Now, when they ask us to factor, it's implied that they want us to factor completely or represent this expression as a product of primes. Well, this factor is not prime because it is still the difference of squares. So I'm going to rewrite the first factor because it is prime and factor the second factor as the difference of squares again. The square root of the first plus the square root of the second times the square root of the first minus the square root of the second. And this is the prime factorization of this expression, which matches letter A. In number 2, we're given a 4-term polynomial and asked to factor it. Well, what we need to notice here is that this expression, 9j squared plus 12j plus 4 minus k squared, the first 3 terms form a perfect square trinomial because the square root of the first term is 3j, the square root of the last term is 2, 3j times 2 is 6j, doubled is 12j. So therefore we have the difference of, we have a perfect square trinomial here. I'm going to factor it as we would a perfect square trinomial to 3j plus 2 squared, and I still have this minus k squared term. Now, this expression is still the difference of squares, which means we can factor it like we did number 1. So I can take the square root of the first term, which is 3j plus 2, plus the square root of the second term, which is k, times the square root of the first term, which is 3j plus 2, minus the square root of the second term, which is k. So this is the prime factorization for number 2. And that matches letter C. In number 3, once again we have the difference of perfect squares, so I can factor number 3 to the square root of the first plus the square root of the second times the square root of the first minus the square root of the second. Now once again, this first factor is prime, so I'll just rewrite it, but the second factor is the difference of perfect squares. So I'll factor it to the square root of the first plus the square root of the second times the square root of the first minus the square root of the second. So this is the prime factorization for number 3. Let's do one more. For number 4, we need to recognize again that this 4k squared plus 4k plus 1 is a perfect square trinomial. And we're subtracting this m squared term from that. So I'm going to factor this perfect square trinomial to 2k plus 1 squared. And I still have my minus m squared term. Now I need to recognize that this is the difference of perfect squares. So I can factor it to the square root of the first term plus the square root of the second term times the square root of the first term minus the square root of the second term. So this is the prime factorization for this expression.